Sir, MCQ 3, 4, and 5.
Oh, MCQ 3, 4, and 5 we discussed. Okay, great. So from the beginning we now try, right? Because our topic is over. And I told you that we will discuss about the vacuum flask, how it is working, isn't it? Like how in vacuum flask the hot liquids remain hot, and in the ice cream container, like the people you see in the streets road, they are offering ice creams, selling ice creams. How?
Sir.
Yeah, walaikum salam, Mahi, how are you? So how
Fine, sir.
the how the ice cream is becoming uh, still remain cold, okay, and we get the benefits, right? So here is the way, like I'm showing you the diagram. It's easy to understand. Then vacuum flask structure. Okay, so look here. We have a simple, very simple one here. We have you have in your house this vacuum flask, right? All of you, and especially during this winter, we are using it to drink. In our house, we use it during the winter time for taking warm water, and sometimes to make tea, right? In our school also, in the tea corner, we have a flask, right? Have you seen?
Yes.
Yeah, so we have this flask in everyone's house, or you saw it. So it is you know, it's a container where we try to stop or reduce the process of heat transfer. Three process of heat transfer: conduction, conduction, and radiation. Okay, by these three processes, heat is losing, right, in the surrounding. So if we can reduce or we can stop heat, then the liquid remains hot for a long time. So it's happening like how we are stopping the conduction and convection. First, you understand it. So it's very easy to understand. You see, here we have stopper, right? Stopper, normally it is made from plastic or rubber. Okay, so it is also insulator, and this stopper is made in a way that, or is fixed in a way here. When you close it, then it is almost airtight, right? As
Yes.
it is rubber, in this container wall, it is fixed. So there is no possibility to air to get in or get out from here. So this way, we have here the trapped air. Okay, inside here, trapped air, and little bit air is there. So we we have here air, but that is trapped air. If it is completely full of liquid, then this is more likely that there is no air inside. But if it is less filled, right, a little bit less filled, not completely filled, and we have a little amount of air inside, and it is air, that air cannot move, trapped. And this way, this stopper is stopping the conduction process. We have here convection process stop, and as it is insulator, stopper plastic or any rubber like things, these are bad conductors of it, right? So they are not like metals that they can transfer heat easily. They will reduce the heat loss by conduction in this part. And the other part of the container, you see here we have double glass shell, right? uh, so double glass shell, inside it there is vacuum. Uh, there is vacuum, and vacuum means hollow, right? Isn't it?
Yes, sir.
So if it is vacuum hollow, then no contact. If no contact, no conduction. If vacuum, that means no fluid over there. That means no gas or no liquid inside it, in this part. So there is no convection possible. So conduction and convection stop here. And now the third process, there is possibility of passing heat transfer by radiation, because radiation does not need any medium. It can pass without any medium. In vacuum, it can pass, right? Isn't it?
Yes, sir.
Yes.
So how we are reducing it? We are giving silver coating, right? You see, in between this, the layer we have, the the outer layer of this, our mirror, back of mirror is painted, right? Uh, then we can have mirror, isn't it? Silver color,
Yes, sir.
isn't it? So we have reflection of light, or reflection of our image over there. So the same way, here we have a reflection of infrared radiation. Heat is infrared radiation, and that heat is reflected back to liquid, reflected back to liquid from this shiny surface. So this way we also reduce the. We cannot make anything 100% efficient, right? But it's possible to reduce, right, as much as possible, isn't it?
Yes, sir.
So this way we are reducing the radiation process also. So in this vacuum flask, we have conduction is reduced, convection is reduced, and also radiation is reduced. So our liquid remains over there uh, hot for long time. Okay, maybe if it is a very good vacuum flask, we can make the condition very good, and even it goes for 2 days, 3 days. When you open, then there is heat loss, right? When you are opening, when you are doing some work, then some air is going inside, there is convection, then there is heat loss. Okay, is it clear? Hello?
Yes, sir.
Otherwise, it will go for long time. Okay. So we have here the same thing is happening in the we cannot say same thing, like similar things is happening in the ice ice cream container the people are selling, right? There is a cork sheet, there is some insulation inside it, and double layer, trap layer, so that there is less possibility to heat transfer outside, okay, or inside. So this way this ice cream becomes stable, right? Cold remains for a long time. people can sell, right? They are taking in the morning, then they are selling till night. Okay, is it clear now? So,
Yes, sir.
so these are our real life examples. That's why I discussed it, so that you can understand the process more, right? Now, we are going to you just write in your notes at the last part, bottom last, you write there about vacuum flask, write the very vacuum flask structure. Do you want to draw it? Like to draw it? Hello?
Yes, sir, we can draw.
Yeah. If you want to just sketch and label, that's it. Then it will be good for you. You can store your writing and understanding. Sumaya, Sumaya, hello Sumaya, Sumaya, Mahi, Monica, hello Farabi.
Yes, sir. Yes,
Uh,
sir.
have you understood everything?
Yes, sir. We understood.
Please take the notes. Take the notes and draw the diagram. Okay. And if you want to write, already I discussed, if you want to write, you can write these things like stopper is reducing the process of process of conduction and convection. Okay. Then beside vacuum, you write uh, is stopping, right? Vacuum is stopping the process of induction and convection. In vacuum, no conduction, convection. Okay. Then silver coating. Silver coating is reducing Mania. So it's disconnected for a while. So we did you write this about the stopper
Yes, sir.
Yes, sir.
and vacuum? You wrote also that silver coating. Maybe you couldn't write. This one is
Sir, what was the stopper one?
stopper one will be it's reducing. It's reducing conduction and convection process. Okay, and vacuum one is stopping.
Okay, sir.
Vacuum is stopping
Yes, sir,
the
I remember.
conduction convection process, and silver coating is reducing the radiation process. Okay, so we have the notes right on this, completely done. Now we have this one, question number one. MCQ. Yeah, Farabi. Farabi,
Yes, sir.
could you please read, my dear, question 1, MCQ 1?
A heater is designed to radiate thermal energy, which change to design decreases the thermal energy emitted by radiation. A darker color surface, a higher surface temperature, a larger surface area, a shinier surface.
Yeah, which one?
That D, a shinier surface.
A shinier surface. Can you please explain? Explain how it is. Your answer is correct. Uh, we have notes on it, right? Like
Yes,
why
sir.
why the answer is D, Dhaka, shinier surface. So can anyone explain it?
Sir, white and shiny objects are bad emitters of heat.
Yes, yes. So we want to decrease the emission of it, right?
Yes, sir.
That's why the answer should be Dhaka. Very good. So I wanted you to get it printed. I think you all got it printed, this worksheet, right? And if you have this note printed, then you write it, the notes here beside shinier surface you write, or you can write on your physics record copy. uh, you write MCQ1, the answer is D. And why it is D? Because shinier surface is bad emitter of it, right? So this is the explanation. Now we are going to question number 2. Yeah, Farabi, continue to question 2, please.
Which statement about the thermal energy is correct? Transfer by radiation does not require a medium. Transfer is from a region of lower temperature to one of higher temperature. Transfer upwards in fluids is mainly through the vibrations of neighboring particles. Transfer in solid is by means of density changes in the material.
So which one is our answer here?
Sir, A.
Yes, exactly. Exactly. The answer is A. Transfer by radiation does not require a medium. And you see why B is incorrect? It's saying opposite, right?
Yes, sir.
It should be from higher to lower. Then why C is incorrect? In fluids, we don't have vibrations of neighboring particles. We have circulation of molecules, right?
Yes, sir.
Uh, and in solids, we have vibrations of neighboring particles, right? In solids.
Yes.
And then D, transfer in solids is by means of density. No, it is in liquids. Transfer in liquids is by means of density changes in the material, like higher density sink down, lower density rise up, isn't it?
Yes, sir.
Okay, so Farabi, question 3, please. Farabi,
In which states of matter does convection occur?
yeah, which one? Yeah,
Sir, gases and liquids only.
yeah, convection occurs in fluids, right? If you
Yes, sir.
if you see the definition of convection, it's written over there that it occurs in fluids. Fluids means gases and liquids, right?
B, sir.
Yeah, Bangladesh. Then Monica. Monica, can you please read 4? Monica. Hello,
A
Monica.
copper rod,
Hmm.
sir, can you
Yes.
hear me?
Yeah, now I can hear you. Yes, please continue.
A copper rod is heated at one end. Which statement describes how heat transfer occurs in the copper? A. Energetic copper molecules from the cooler end to the hotter end. Energetic copper molecules move from the hotter end to the cooler end. Energetic free electrons move from the cooler end to the hotter end. D. Energetic free electrons move from the hotter end to the cooler end. C.
So you are very close.
Sir, it should be B.
Okay, why not C?
Sir,
Because that says cooler end to the hotter end.
So it should be from hotter to cooler, right?
Yes,
In
sir.
in hotter side we have more energy. We have the property of heat that heat should go from more hotter place to cooler place because more hotter place has more energy, right? So more energy will be distributed to less energy region. Is it clear, Monica?
Yes,
Hello?
sir.
It's clear, right? Great. So we are now going to next one. 5. Yeah, Monica, you continue 5, please. 5, Monica, 5. Monica, are you there? Hello. Yeah, sorry that is disconnected again. Yeah, Monica, are you seeing? Hello, Monica. Monica. Hello.